Okay, this next chapter we're going to cover is chapter 11. It's on fertilization. I realize that you don't do a lot of fertilization right now. That may change in the future, especially if we can persuade DOT to purchase some really good, long-lasting fertilizer that should be applied only once a year. In some kinds of high-maintenance areas, if you do need to fertilize, then it would only have to be once a year. Now, that hasn't been done yet, but in any case, if you do ever need to fertilize, even if it's not on the row with your DOT positions, oftentimes, since you're already in landscape, chances are you're doing a lot of fertilization outside your job. So anyway, this is to just familiarize you with fertilization. How many people do fertilize on the job? Anybody ever fertilize? Yeah, that's typical. Okay, so but that may change. Okay, again, this is chapter 11. You want to change to switch over to that chapter. And just a little bit about fertilizers. What are fertilizers? Just like we talked about, what are pesticides? At this point, any fertilizer that we use for the landscape is an artificially manufactured mineral product. Natural fertilizers are manures and composts, things like that. They can be very useful in agriculture. Even some composts and so forth can be used in the landscape. But chances are any fertilizer that you're going to be using in the landscape is going to be a manufactured, mined mineral coming out of the earth. The main thing to remember about these fertilizers is that they contain all of the natural elements that plants need to survive. There's about 17 natural elements in the earth, in the soil, that plants need. If they don't get all of those, they'll eventually die from a deficiency of one, at least even of one of those 17. For the most part, though, these three elements here, nitrogen, phosphorus, and potassium, are the three main ones that all plants need. Most fertilizers will contain some nitrogen, some phosphorus, and some potassium. They'll also contain all the other nutrients in very small amounts that are necessary for normal plant growth. For example, iron and manganese and zinc and some of those, magnesium and calcium and some of those things. But the three, the big three here are nitrogen, phosphorus, and potassium. They're usually abbreviated by the chemical symbol that they go by, N for nitrogen, P phosphorus, and the chemical symbol for potassium is K. So N, P, and K are the major elements contained in fertilizers. Why do we use fertilizers? Well, the soil eventually is going to run out of these elements, and especially in an agricultural situation, and especially a landscape situation where you're constantly growing plants, and the plants take up the minerals, and then we harvest the plants and do something else. Nothing goes back into the soil. So sooner or later, the soil runs out. It becomes deficient. That's especially true in agriculture, because in agriculture, you're pretty much harvesting the entire crop, taking it out, and very quickly, agricultural lands can become deficient in certain things. But even in the landscape, even though oftentimes in the landscape, when we're mowing, we put the clippings back in and so forth and so on, we're still taking out more than we put back in. Only in situations up in the rainforest, for example, where plants and animals die, decompose, and all of their elements go back down into the soil. That's a sustainable, what they call sustainable, kind of a supply of the nutrients. We don't have that in a landscape. So that's why we have to fertilize. And basically what you're doing is all of these various elements, all of the 17 elements, are actually in the soil as a particular mineral compound. They're normally not there just as a pure element. NPK, nitrogen, phosphorus, and potassium, for example. Nitrogen is there not just as nitrogen, but as nitrogen compounds. The same for phosphorus and potassium and all these others. So all of these eventually then get into the soil. They're broken down, various kinds of more complicated compounds are broken down to smaller parts and finally into forms that the plant roots can take up. And those particular forms of the nutrients are the same whether it comes from a fertilizer, a manufactured fertilizer, or from organic fertilizers like compost and manure and so forth and so on. All of the elements are exactly the same no matter where they come from. The big difference is with these particular kinds of fertilizers, it's more immediate. These things don't have to be broken down as much in order for the plants to use them. So here again, the most common ones that you want to remember that we're replacing are nitrogen, phosphorus, and potassium. How much? N, P, and K. Here again, first of all, these are the three main ones that plants need the most, and nitrogen is the one that plants need. That's number one. They use more nitrogen and need more nitrogen than any of the other elements put together, pretty much. But then phosphorus and potassium in smaller amounts. But how much, we need to know when we put a fertilizer down how much we're putting down. How much nitrogen is there in a bag of fertilizer? How much P and K? You probably all know that there's lots of different kinds of fertilizers, all different kinds of mixes for amounts of N, P, and K. Well, the way to tell that is to look at the three numbers on a bag, and almost all fertilizer bags have these three numbers someplace on the bag. Oftentimes it's much more noticeable than this. This one says, for example, 29,210. Those numbers refer to the percent by weight in order of N, P, and K. So this particular bag of fertilizer has 29% total nitrogen in various forms of nitrogen in there by weight. So if you had a 100-pound bag, you'd have 29 pounds of total nitrogen. 2% in phosphorus and 10% in potassium. That particular formulation here, 29,210, is a typical turf, grass fertilizer, where there's a lot more N. The first number is always higher for turf fertilizers. Talk a little bit more about that in a little bit. So that's what these numbers stand for, and they're very useful in later on determining how much of a particular fertilizer to apply. This one, for example, is just an Ace Hardware homeowner type a concoction of 33 and 3, pretty close to the 29, 2, and 10. Here's one that is used more for fairways and so forth. Professional turf fertilizer, 21, 4, 11. So all of these can have different combinations of the N, the P, and the K. Okay, here again, still talking about the N, the P, and the K. Certain ratios, certain equal parts of N and P and K are more important depending upon the kind of plant that you're fertilizing. Turf, for example, grasses need a lot more nitrogen, about 4 times as much nitrogen as the P and the K. So a ratio, if you take the lowest number divided into all the other ones, it's called a ratio, of 4 parts nitrogen, 1 part phosphorus, and 2 parts potassium, 4 to 1 to 2. Something along the lines of total amounts of 37-15. That's about a 4 to 1 to 2 ratio. Would be a typical turf grass fertilizer analysis. And again, the reason being that N is for actually, results in all plants growing green leafy tops, the top part of the plants. The leaves are fed by nitrogen. And with grass, that's what we're constantly cutting off. You're constantly cutting off the leaves of grass. So you're constantly losing the nitrogen that the leaves take up. So you have to replace it. Trees and shrubs, normally we're not cutting as much of that. They can get along better with a 1:1:1 ratio of N to P to K. So something like 16/16, 14/14, 15/15 would be a typical kind of formulation that they would be using for trees and shrubs. But all of and then palms are a little bit special, especially single trunk palms, well, even clumping palms. They need more of what's called the minor elements, the lesser needed elements, and magnesium and iron actually are two that they need more of. So here again, a sort of a balanced formula of 14/5/14 with more iron and magnesium in the formulation is a good palm formulation. Less phosphorus. Actually, phosphorus now in a lot of areas, a lot of states is being banned. You can't put down fertilizers with phosphorus, mostly because it's adding to the soil pollution, soil runoff and water pollution. That hasn't happened here yet. But there's more of a push now to use less phosphorus than there used to be. And here in Hawaii, there's another reason for that, in that most of our clay soils here really grab a hold of phosphorus and don't let it go. They grab a hold of it and don't give it up. So a lot of plants can become phosphorus deficient, even though there's a lot of phosphorus in the soil. And that's fairly common. The reason for that is more because of the soil pH. It's either too acidic or too alkaline, and it combines or holds on to the phosphorus. So as far as ratios are concerned, you'd be using something like this, 1:1:1s for trees and shrubs, a palm formulation. Grass would be more of a higher number in the N. Also, too, slow release formulations. We'll talk more about that in just a minute. But by slow release, we mean these nutrients aren't, when they're dissolved in water, they don't all become available right away. It's a slow, gradual release so that it'll last a lot longer. There's a lot less chance for burn as well, too. And that's the kinds of fertilizers that we're trying to encourage, at least DOT and other people also, to be using. Okay, nitrogen again is the most important of all of the minerals, even of P and K, because it keeps the plants green. Nitrogen is responsible for making almost everything the plant makes, but some of the most important things are the chlorophyll, the green chlorophyll in the leaves, the protein that the plant leaves are made out of. Nitrogen is a part of almost every different plant product. So it has to be supplied in a lot higher amounts. And therefore also it runs out very quickly from the soil. As far as fertilizers are concerned, though, there's two different forms of nitrogen, ammonium and urea, that is normally in the fertilizer. So most of your total nitrogen in almost all fertilizers is either an ammonium product like ammonium sulfate or ammonium phosphate, and or urea. Oftentimes it's both. It's a mixture of both. So that part doesn't really change. This 21, 4, 11, 33, 3, 28, whatever, would all have mixtures of ammonium and urea. And how much of those mixtures would determine what the total nitrogen is, either 21%, 30%, or whatever. So, and again, since nitrogen is the most important element. That's the one thing you really want to look at. What does a fertilizer have as far as nitrogen is concerned that makes it different from any other fertilizer? And one of those things is going to be in the form of either ammonium or urea. Now, these two particular forms, ammonium sulfate sold as just it's by itself, 2100, ammonium sulfate, or urea, which is about 46% nitrogen, are commonly sold just as a source of nitrogen. They don't have P and K, so they're not considered a complete fertilizer. But at the same time, both of these are used to mix together to form the nitrogen part of the fertilizers that do have the P and the K. They're called quick release nitrogen fertilizers because as soon as they're dissolved in water, they go into solution, they sink down into the soil, and the roots, it's available for the roots to take up right away. Now that's good and that's bad. What the good thing about that is that they are quickly available. If you have any kind of deficiency, within a day or two, you're going to see a big greening up. Now, and a spurt in growth. Well, that's not always good if you're talking about lawns. That means you're going to have to mow a lot more right away, right? The downside of that, though, is it doesn't last very long. These things go into solution, they go into the soil, taken up by the roots very quickly, since they are taken up, and also nitrogen leaches down through the soil very easily, a lot of the nitrogen actually is lost down into the lower parts of the water table, just because it moves down through with the water. So nitrogen, even though it's the most important element, is the one that doesn't stick around very long in the soil, which is another reason it has to be replenished quite often. So these are normally referred to as quick-release nitrogen fertilizers or water-soluble nitrogen fertilizers. And up until about 15 or 20 years ago, this was really the only form of fertilizer that was available with this particular kind of nitrogen, either the ammonium form or the urea form. About 25 years ago, they began to develop newer forms of nitrogen sources, and these were called slow-release nitrogen fertilizers. The first one that came out was called sulfur-coated urea, and it's kind of shown here in diagram. All it is, really, is an inner core of a little granule of urea, which just the same as if you buy urea by the bag, and then it was coated with sulfur, with molten sulfur. They just had big tumblers, and they poured the urea into these tumblers with the sulfur, with the molten sulfur, and just kind of coated it like a batter, and that resulted in a little granule of ammonia of urea that's kind of protected from dissolving right away by the sulfur coating, which doesn't dissolve right away. And then oftentimes there's a sealant actually after that, sometimes not. But with this particular kind of nitrogen called slow release, the water, once it hits this little pellet, this is a tiny little pellet now, it'll hit the pellet. The sulfur has little pukas in it, little channels where the water can slowly leak in, and the water then would slowly come into the urea and slowly dissolve that urea, and it would leak back out of the pellet into the soil. So you can put more of this down, and it'll last a lot longer. One of the drawbacks of these, going back here to the quick release nitrogen fertilizers, again, is that they are so water soluble and dissolve so quickly. All of that salt going out all at once can actually suck the water right out of the roots, and it turns the grass brown. It's called burn, fertilizer burn. Have you ever held a handful of urea in your hand, or a handful of ammonium sulfate, or any kind of fertilizer in your hand for any length of time? I'm sure some of you guys have done that, right? What's it feel like after a while? Can you hold on to it very long? What begins to happen? It starts to get kind of sticky at first, and it sort of begins to dissolve. And after a while, pretty quick, it starts to sting, right? If you have any little cut or anything, it really stings bad. What that's doing is sucking the moisture right out of your skin, and it begins to dissolve that fertilizer, which is the same thing it does on grass. If it sits on top of grass, it'll suck the juices and the moisture right out of the grass. Or if it sits there and it's not dissolved very well in the soil, it'll suck the water right out of the roots. That's called fertilizer burn. That's one of the main downsides of using these particular kinds of fertilizers. On the other hand, if you have this slow release stuff, since the water leaks in slowly and the urea leaks back out slowly, it doesn't get out there all at once, and it doesn't burn. And also, it'll last 2 or 3 times longer in the soil. So it's a slow release, longer lasting kind of a formulation. On the bag, it'll oftentimes say slow release nitrogen forms. Sometimes it'll say water insoluble, meaning it doesn't dissolve well in water, WIN. There's several different forms now. Sulfur-coated urea was one of the first. Now they have other things called urea form, IBDU. They can last up to 6 months. One application can last up to 6 months. So rather than putting down ammonium sulfate every, say, 4 weeks and risking burn, you can put this stuff down. It'll last 3 or 4 times longer. So it's safer to use, less likely to burn, and less likely to leach into the soil, because it's a more gradual kind of a release. Okay, now lately, the next generation of fertilizers are being called the ultra slow release fertilizers. And the big difference here, you ever heard of Osmocote? You all have, right? Osmocote. It's a fertilizer they use in nurseries, usually for pots. It's got a little plastic coating around each pellet, and it's really slow release stuff. But when it's all gone, it leaves that little white empty sack of plastic behind, so it's kind of unsightly. But it's been around for a long, long time, used in potted plants mostly. This is a similar kind of a thing, but it's meant for turf. It could be used for anything, but it's really meant for turf. It's a formulation where, again, they have a little prill, a little granule of a manufactured product, and again, inside here now are the nutrients. But in this case, it's not just urea, it's not just nitrogen. It's nitrogen, phosphorus, and potassium, all 3. So this is a very slow release of the 3 main elements, not just N. So this can give you a much more complete feeding of the plants, not just N. And here again, there's a special waterproofing around the outside, special membranes and so forth, that again, it has to dissolve from the inside out. But this membrane is activated not just, actually it's very slowly activated by water. It's more temperature, microbic action, a lot more like compost would be, organic fertilizers would be. So you can put this stuff down and not have to worry so much about burn, because it's a very slow release thing, and it's a NPNK product. For example, here, this little graphic here shows if you had the regular slow release sulfur-coated urea, if you put that down here, this is the line, anything in here is good. Any amounts of nutrients in this, between this line and this line, would be good. That's where you want to keep all your nutrients as far as how much is in the soil. If you applied sulfur-coated urea, put it down here in January, February, say February or so, very quickly these nutrients and basically nitrogen is going to be released, and it's going to be available in the soil, right in this here. But if you put a little bit too much down, you run the risk of getting too much too soon. So you can run the risk of actually damaging the plants again because of burn or just getting too much for a short time. And then that nitrogen runs out again, and then you've still got a long time here, a couple months, that keeps it in this range, and eventually it runs out. And at that point, you've got to put it down again, and the whole thing over again. 1 year's time, you have to put down 4 applications to keep the soil with adequate amounts of just nitrogen over the year's time. Now, the major cost probably for that, putting down multiple things, isn't just the fertilizer, it's the labor. Labor costs a lot more than the fertilizer does of it. So you're going 4 times a year here with applications. If this was ammonium sulfate, you'd be putting down maybe 10 applications a year with a high risk of burn each time you do it. Really rapid growth and boom, down again, spurts of growth and times when it's a lot slower. So compare that now with 1 application of this ultra slow release stuff here that again doesn't have just the N, it has these other guys in here too. You put it down again in February, very quickly it'll begin to dissolve and it'll come up into the area where it's adequate. You've got enough in the soil, but it's N, P, and K now, not just N. And it over a long period of time, it's a controlled release of all of those nutrients up to a year. So here again, you're down into the deficient range. You might want to put another one in, say in February of the next year, and you've got a 12-month release. Here in Hawaii, because of the temperature, higher temperatures, it may only last more like 10 because we have higher temperatures, but still, that's good. It's still basically a once a year kind of application. This if and when the DOT decides that it's going to fertilize only high maintenance areas, this would be the type of fertilizer that we're encouraging them to buy. It's more expensive, but it's not 4 or 5 or 6 times more expensive. And if you just compare labor itself would be 25% of the labor is required as using other kinds of fertilizers, because you don't have to put it down as much. So it's cost saving and also labor saving. So depending upon what particular kind of fertilizer you use, whether it's ammonium sulfate or urea just by itself, or whether it's sulfur-coated urea or these regular slow release kinds of things, or this thing, that would determine how much you're going to put down. I know it's hard to stay awake after those sandwiches. It's nap time. I know. Okay. If you look at a bag of fertilizer, on the back there's an area called a little block called the guaranteed analysis, and it's on almost all bags of fertilizer. It's just a little on the back here. Actually, the label on the fertilizer does tell you quite a lot. Not as much as a pesticide label, but it does tell you quite a lot. How much to put down and what's in it, and so forth and so on. But this particular little analysis here is really important to look at, mainly to see what kinds of nitrogen are there. Because again, all the rest of this stuff, the P, the K, it's all about the same. It doesn't matter what kind of fertilizer you have. Those are all supplied by the same general kinds of compounds. So it's basically in the kind of nitrogen that you're buying. And what you want to look at is how, okay, here's for example, this is the 26-4-12 formulation. So what would you look at? What would you be using this for, most likely? What kind of plant? 26-4-12. Grass, yeah. This is the grass fertilizer. Higher in the N and slower in the P and the K. And again, this would be a good fairway greens, actually a good greens fertilizer too. But total nitrogen is 26%, 26 total nitrogen now. Now this tells you what kinds of nitrogen are mixed in together to form that 26%. And that's what you want to look at. That's the most important thing you're buying, is the nitrogen. This one has of the 26, a little bit more than 3% of ammoniacal. That means ammonium sulfate, okay? So a little bit of ammonium sulfate. 9.7 water insoluble. What's the water insoluble nitrogen? What kind of nitrogen would that be? If it's not going to dissolve real quick, it's the slow release stuff. Yeah, it's a slow release. So some kind of slow release. You see that little asterisk there? Okay. 3.5% of regular urea, and then 9.7 other water-soluble nitrogen, other kinds of water-soluble. Down here at the bottom, this is what you want to look at, the final amount of slowly available nitrogen. And this is in the form of methylene urea. This is really good stuff. And one called IBDU. This stuff is really going to last for a long time. Almost 20%, most of this nitrogen here is in the form of a really long-lasting nitrogen formulation. It's going to last a long time.
How long are we talking? Months or years?
Not years, but in this particular case, it's got IBD, probably 6 months. Yeah, 6 months, something like that. 5 to 6, something around. But only N now, not the P and the K, you know. But that's not so much of a problem here in Hawaii. P and K normally aren't deficient. The soil's not going to run out as quickly of the P and the K. It's the N. Okay, so this would be a really good nitrogen source. If you compare that with this one, this one is 30% N. So you think this might be better, right? It's got more N. It's 30%. But if you look at what kinds of N here on the back of the bag, this one only has about 8% slow release N. It's only got about a third as much. The rest of it's ammonium sulfate. You might as well buy ammonium sulfate, same stuff, or urea. So that's the main thing to be looking at when you either use or purchase any kinds of landscape fertilizers. See what kinds of N is involved. Okay, again, just like pesticides, you can't use too much. Be careful. If you use too much, especially of the water-soluble, quick-release kinds of things, it can leach into the soil and pollute the groundwater. Nitrogen can. Too much phosphorus, the middle number, P, even though it sticks to the soil, to the clay soils, during soil erosion, you know, when the soil is washed into streams, it does dissolve then, and it gets into the water and causes algae bloom. And a lot of algae starts to grow, and that kills the fish. That's a pretty serious problem, especially on the mainland, but as well here too. Actually here, we're seeing a lot of results of that down as the streams enter the ocean, into the coral reef. There's been a lot of damage because of that. In the Kaneohe Bay, for example, is one good example. So, and of course, avoid spreading fertilizers on slopes, even though they're vegetated slopes, because runoff is much more likely on slopes, and you're much more likely to, here again, you know, pollute the groundwater or pollute the streams. So there are some things to consider. It's always a good idea to irrigate, to water well right after you apply the fertilizer. Here again, if you're applying the quick release fertilizers or even the sulfur-coated ureas, it's important to get it dissolved quick and enough water to dissolve it to move it into the soil. If you don't water it long enough, then you're just going to get it to dissolve, and it's going to be a really high concentration of salt that's going to burn the leaves and the roots. So you want to water it well and move it into the soil. Water actually dissolves it and moves it down into the soil. And once it's into that area, you're safer than you would be if it sits up on here on top of the blades of grass and just slowly dissolves. Here again, not quite as important with slow release fertilizers, but still it's a good idea. The ultra slow fertilizers now, it's not as necessary. If you use this ultra slow stuff, water doesn't activate it nearly as much. So you can let that sit on the grass for 4 or 5 days, and you don't have to worry about irrigation. That's a good one to use if you don't have an irrigation system. If you don't have an irrigation system, you're kind of, taking chances by putting down fertilizer because you want it to dissolve right away. And if you're depending on rainfall, that may not be, for a day or 2 or 3 or 4. Question?
When you were showing the percentages of nitrogen and stuff on the bag, what was the chlorine for? It was like a high percentage of chlorine.
Of chlorine? Well, why? Because of what?
What's the chlorine for?
There is no chlorine.
The one down there it said 10% chlorine.
Where? Oh, that was probably potassium. Potassium. Yeah, okay, let's go back. Here, you mean? Chlorine not more, yeah, not more than 10%. Now, why they would put, I don't know why they'd put, sometimes they use chloride salts, like magnesium chloride. Yeah. Chlorine actually is an essential element. Plants do, but not that much, So yeah, that's saying there's not more than 10. Normally that's really high. Most of them don't have anywhere near that. Yeah, I did notice that. Yeah. Okay, so always a good idea to irrigate immediately after. If you don't, you can run the risk of fertilizer burn. So therefore, irrigation systems are oftentimes desirable when you irrigate. When and where, okay, this is DOT. When and where would we be recommending applying fertilizer? Well, here again, we don't do it, period, right now, for the most part. But where, let's look at there first. In very high visibility locations, coming in from the airport, that new installation that they just put down for APEC. Anybody, anybody involved in that? Putting down the median strip of the palms and the grass coming down Nimitz Highway? No? I think a contractor did that. Anyway, it looks great, but we need to maintain it, and in doing that, we may need to fertilize it every once in a while. So areas like that, areas on the poly, for example, coming down into town, as you get closer to town, in the medians, basically, we could use some fertilizers there once in a while. Other areas, very high visible areas, where we want to keep it really as nice as we can. And that's a very, very small amount of land compared to everything else that DOT takes care of. Media here, for example, on Oahu, medians with St. Augustine grass. The big triple whammy for a lot of these medians is St. Augustine, alpaca, and monkey pod trees or shower trees, right? That's kind of the combination they use a lot of. Those areas, once in a while, could use some fertilizer. There's some areas even with El Toro zoysia. They definitely could use some once a year kinds of fertilization. So we're not talking about a lot, only high visibility areas. When? Well, one application a year would be enough if you had this ultra slow fertilizer. Once a year would be plenty. Any other kind of fertilizer, it wouldn't be practical to do it more than twice, probably. So again, 1 to 2, but you're not getting the bang for the buck, You're spending all that money on labor and putting down something that's only going to last for 3 months. So 1 to 2 applications of some of the slow release stuff to be practical. Okay, where wouldn't we apply it? Well, basically where we're not applying it now, right? Most rural roadsides and medians, of course, bare soil, sparsely covered slopes, definitely don't put down fertilizer or pesticide or anything in those areas, likely to wash away. Anything close to streams and ditches and swales, where again it's likely to wash out into the streams. So basically we're saying very small areas in high visibility areas. This is something, again, that has to be set up. HDOT would be ideal. If HDOT would purchase this fertilizer You get it cheap on contract, and then supply it to either contractors or you guys as it's needed. Then we know exactly what's being put down and when it's being put down. If that happens, that would be ideal. There would be some reporting involved, just like there's reporting involved now on how much was used and when, but ideally once a year. Okay, this is probably, other than what kind of fertilizer, is the second most important thing. How much fertilizer should you put down at any one time, any time that you put down? And here again, there's a little formula. This is not nearly, I don't think anyway, as extensive as the pesticide calculations. But this is a little formulation that's in your manual. I think it's 65. It's in the fertilization chapter anyway. But how much fertilizer that you put down, not just for turf, but for trees and shrubs and everything too, depends pretty much on how much nitrogen is needed by the plant. And the rule of thumb for most plants, especially if you're using a soluble fertilizer, is 1 pound of total nitrogen. Not 1 pound of the fertilizer, but 1 pound of the total nitrogen. So that's the normal rate for quick release fertilizers is 1. For slow release fertilizers, you can put down a little bit more, less chance to burn, it'll last longer. So 1.5 pounds of total N. And then these ultra slow, 4 to 5. And again, that's one of the reasons it's going to last a lot longer, put a lot more down. So these are the general recommended rates that we would work with to figure how much total fertilizer is going to be put down. I'm sorry, that wasn't this. Okay. Trees. And go back here. Notice it's per 1,000 square feet. Now that could be per acre too, but generally with agricultural crops, you're usually working in big areas in acres. Oftentimes in landscape, that's too big, so we work in units of 1,000 square feet. There's 43,000 square feet in an acre, a little over. So we work in units of 1,000. A little easier to work with. So for turf, the total N per 1,000, you just have to determine the area, length times width or whatever, some way to calculate the total area that you're putting it down. For trees and shrubs, the recommended amounts are a little bit more, 2 to 3 pounds if you're using the slow release, ultra slow 4 to 5. If you're using the quick release stuff, 1 probably would be better. For trees and shrubs, it's probably better to use these kinds of formulations anyway. And again, how often? Once a year, no matter what, for all practical purposes. Twice a year maybe in newly planted trees and shrubs. If trees and shrubs are well established and they're in areas that are fertilized once in a while anyway, the grass is being fertilized once in a while. Usually trees don't have to be fertilized once they're established, 5 or 6 years old. Okay, determining the area. This little bit of math involved here. The area, determine the area for turf you can just use the length times width. If it's a rectangle or whatever, if it's a triangle, you can use formulas for that. But for turf, it's whatever that area is, length times width, and let's say this would turn out to be, say, 5,000 square feet. That would give you the total area that you're going to put it under. At a rate of 1 pound per 1,000, you can determine then how many pounds of total nitrogen it's going to be. There's a little formula for that. For trees, a little bit different. Trees, their roots oftentimes are thought of as just going out to the drip line. That's not true at all. They go way beyond that. But the effective area underneath trees to fertilize, for all practical purposes, would be underneath the drip line, underneath the canopy. Roots, though, here, for all trees, this size of tree here, the roots would go way out into here, way, way, way past the drip line, but not very deep. Tree roots only go about 18 inches deep. About 95% of tree roots are 1.5 to 2 feet deep, not way down in there. If you've ever seen one uprooted, you'd see, you know, it's not very much root zone there. And especially in urban areas where there's compacted soil and so forth. And we'll talk more about that when we talk about planting trees and pruning. But anyway, in order to determine the area underneath a tree, you have to go back to the formula for a circle, which is pi r squared. In the 8th grade, I think we, then more, it's like 2nd grade, you learn this kind of stuff. Pi is a number, a set number, which is always 3.14. And then times, now the radius of a circle is the distance from the center out to the edge. And it would be like the hands of a clock. It's the same all the way around, right? Okay, that's called the radius. The distance all the way through is referred to as a diameter. But we're looking at half of that, the radius here. So what you do is measure the distance from the trunk of the tree here out to the outer drip line. Guesstimate, you know. In this particular case, it's 25 feet. So you take the radius 25 times itself, that's what this square means, times itself. So you would, on a calculator, and we'll do this here in a little bit, you would take 25 times, work backwards, 25 times 25 times 3.14, and then hit the equals, and that's it. That's just one operation. And that would give you then the area underneath the circle. And that would tell you then how much fertilizer to put down. In this particular case, we have a 25-foot radius here, 50 feet across the whole thing. So 25 times 25 times is a little bit less than 2,000. So in other words, we have about 2,000 square feet underneath the canopy there in what's referred to as a root zone to spread the fertilizer. Now we could spread more than that, but this would be as much as we would need to do. So that's how to calculate the area to be fertilized. Hedges, you figure hedges, just little shrubs planted close together, right? Figure that the root zone, the effective root zone of shrubs and hedges go about 10 feet in all directions. So if you take a hedge that's 50 feet long, the root zone would be out in this shaded area here, 10 feet from the edge, 10 feet from the middle part. And then just fertilize that area. Just fertilize in this area here. So in this particular case, you would just figure the area of the rectangle, which is 50 plus 10 plus 10 would be 70 and 20 feet wide, a little over 1,400 square feet. That would give you the total area. And from that, you can determine how much fertilizer to put down at a rate of, let's say, 3 pounds of total N per 1,000 square feet. And we're getting up to the formula here for that. Okay, here's the formula. This is the one that's in your book. I've got some calculators. I don't know how far they'll go. Maybe take 2 per table and pass them on back. I think we have enough for that. I'd like you to get a little bit more comfortable with this working, this particular formula for determining how much fertilizer to put down. It's similar to what Joe was showing you with the pesticide, to show you how much of the product are we going to use. We got a napkin here. Oh, I want these back, by the way. This is not like your manual. Yeah, let's put the light on. Thanks. Okay. Can you find that? It's in the fertilizer chapter. 240, 220, page 220, 220 in your manual. If you want to turn there, it's in the manual here. So you don't have to memorize it, but it's an easy kind of thing to remember. Pass those on. Okay, here's some labels for this ultra slow stuff. You can take one each. Okay, everybody get a. Okay, let's just take some examples here now in figuring how much fertilizer we would need to use. In this case, we'll use the tree example. Going back to this tree here. This is the area that we're going to fertilize here, okay? It's about 2,000 square feet, okay? So now, the next thing we want to know, we know how much we're going to, the area, how much fertilizer should we put down? Okay, so let's go back to this page here, and the formula is the recommended amount of total N for that particular kind of plant. Well, for trees and shrubs, what do we say? 2 to 3. Let's use let's use this slow release. 2 to 3 total N recommended. And it doesn't matter what kind of fertilizer we're using. It's 2 to 3 pounds of total N. Okay, so let's use that recommendation here. Okay, so here we have the recommended amount of nitrogen for that plant divided by the percent of nitrogen in the fertilizer. So we can use any kind of fertilizer we want. We just have to plug that into the formula. Then we get the total area to be treated and divide that by 1,000 because this rate is per 1,000 square feet. So that we need to know how many units of 1,000 square feet do we have. So this little, there's no cross multiplying here. It's just this times this, okay? So let's say that we're using 1616, very, very common fertilizer for trees and shrubs. 1616 does have about half of the nitrogen as a slow release form. So the area that we're going to use is 1,962 square feet, or approximately 2,000. So all we need to do now is plug in these numbers. Well, the recommended amount of N is 3, right? Divided by the percent of nitrogen in this fertilizer, which is what? 16, right? Okay, now if it's a percent, so we want to express that as 0.16. Don't divide by 16, but divide by 0.16 times the area here, which is 1963 over 1,000, which would be 1.96, or 2, basically. Okay, so on your calculator, go through those calculations. Now, we're only using 3 because we're using the recommended rate of 3 pounds of 1616. Okay, so here now, we're going to end up with about 37 pounds of triple 16 to put down under that tree. That would give us 3 pounds of total. That's quite a lot of fertilizer, right? Okay. Now, let's look at another kind of fertilizer. Rather than triple 16, let's say we use triple 10. Okay, figure now, using the same deal, we don't have any triple 16, we have triple 10. How much triple 10 are we going to have to put down to cover that same area? What's the only number that would change in the formula? Well, no, we're still going to use the rate of 3 pounds. This one right here, right? Right here, we're only using 16 because we're using triple 16. Now we're using triple 10. So now it's 3 divided by 0.10 times the same thing. Okay? So how much does that, calculate that out. And how much fertilizer do we need now? Go ahead, do it. Do it. It would be 3 divided by 0.1 times 1.96. So rather than 1875, this number is going to be what? 30, right? 30, because it's only 10%. Times 2. You're going to use almost 60 pounds, yeah, of fertilizer. And that's because triple 10 doesn't have as much in. You know, it has the same stuff. You just have to use more of it. Which one would you rather use? Well, I'd rather use triple 16. Right. So really the bottom line here is using the fertilizer that has the most N is the easiest and probably the most economical too. Even though trees and shrubs needs N, P, and K, using something like a high nitrogen turf fertilizer would be okay too. Something like 30% N, you would have to use a lot less. Okay? So this is a recommendation for trees and shrubs. Let's look at a turf. Okay? Another example. Okay. Okay, one more example here. What? You guys are having way too much fun here. This is too boring to have that much fun. Okay, let's say here again. We have a turf plot. 100 by 50. What's the area? Equals what? 5,000? Okay, so we have 5,000 square feet of turf. And if it's a triangle or whatever kind of thing, we can always use different formulas to figure out the total area. Let's use, in your, we just handed them out, the turf formulation. Which of these three would be the best turf formulation that we just handed out? 19, 5, 10, 14, 4, 14, or 12, 12, 12? 19, yeah, the 19, and actually something even higher than 19 would be even better, right? But these are these ultra slow stuff, okay? So let's use this 19, 5, 10 formulation, and we're going to use it, since this is a super slow formulation, we can use a lot of it without as much chance anyway to burn. So let's use 19, 5, 10 at a rate of 5 pounds per thousand. Okay, jot that down. Let me write it down here. There you go. Okay. So you can use this formula here, same formula. What's this top number going to be? Recommended amount is what? Now this time we're using what? 5, yeah, at a rate of 5. That changes, see? That rate will change depending upon what kind of fertilizer you use. So it's all kind of based upon the type of fertilizer. So now we have 5 divided by what? Here. 9.19? Yeah. Times 5,000 over 1,000, or 5, okay? So what's 5 times 0.19? Got calculators there. 5 times be 100 would be about 98 or something like that. What is it? What is it? 5 times 0.19. It's about 100, right? 95? Okay. So times 5,000 divided by 1,005. So it's about, oh wait, it's not 100, it's 10, yeah? What is it? 9 something? 0.19 divided by, I'm sorry, 5 divided by 0.19. 9.5? No, okay, 9.5. Okay. Times 5 is about 46 or 7 pounds, right? Okay. So in this case, if we were using the ultra slow stuff over 5,000, we could put down about 46 or 47 pounds of the slow release stuff. That would be enough to last the entire year, and it would be enough, again, not enough to burn. Okay, so as far as the formula is concerned, then you need to know what kind of fertilizer and also the rate. Okay, what should you do before fertilizing? It's always a good idea to mow the grass a few days before. Don't fertilize a freshly mowed lawn. Let it heal for 2 or 3 days. And definitely do not mow immediately after, especially if you're using the slow release stuff. What would happen if you mowed the day after you put down the ultra slow stuff? Chop it all up, right? Because the whole thing depends upon that little prill staying put together. If you use a mower, you're going to suck it up, chop it up, and put it back, and you've got immediately released fertilizer. You ruined the whole thing. So don't mow immediately after fertilizing. It's always a good idea to wait another couple of weeks before you mow again. Irrigate right after. You should have the irrigation system in good working order, especially if you're using the quick release stuff. Water well the day before fertilizing and then the day of. But don't fertilize grass that's either too wet or too dry. Too dry more likely than too dry. Too dry, it's going to be in a drought situation. You're likely to injure it that way too. So again, mowing and watering a couple of days before would be a good idea. Okay, how much fertilizer again to apply, or how should I apply it? Well, one way you don't do it is hand feeding, especially in turf. Shrubs and things may be okay under shrub beds. But it's really important on turf to get a nice even spread, and you can't do that with hand spreading. So use a calibrated rotary spreader. Don't fertilize turf, especially by hand. Use the correct application pattern as you're using the spreader. We'll look at that in just a second. Correct overlap. Many of these rotary spreaders require an overlap. Any excess blow back off the road onto the sidewalk or off the sidewalks into the grass, and then again water again right away. Some of the kinds of spreaders you can use are a belly spreader like this for small areas, medians and so forth here. Holds up to about 15 pounds. These are kind of hard to use, especially if you've got a belly. It should be a belly-less spreader because it gets in the way. But it'll hold up to about 15 pounds. Small areas works okay. Larger areas you can use the push kind that we're going to use today, or motorized types for, this is for the poly, going up the poly. That's about, I don't know, 15, 20 feet, probably one pass with a good spreader would be enough to cover that area. Possibly interchanges, high visibility interchanges once in a while. Not very likely, but once in a while. Or you would need bigger spreaders, ones that are pulled by trucks or whatever, or more motorized kinds of things. Normally, though, what you're going to be using is this kind of a spreader here. Okay, again, just like in pesticide, we have to calibrate the spreader, because once you've determined how much fertilizer you're going to use and what kind of fertilizer, you can't just pour it into the hopper and go, right? You have no idea how much is coming back out of the hopper, out of the spreader. So the next thing would be very similar to what Joe was doing out there with the sprayer. Get used to how much is coming out. And that's necessary to determine really how much you're putting down. Avoid getting too much or not enough. Calibration of a spreader really depends on three things. First of all, the type of spreader you're using, that does make a difference. They behave differently, even different makes. But more importantly, the kind of fertilizer being used, and you as the operator, how fast you're moving. The faster you move, the less you're putting down over a certain period of time. If you move really slow, you're putting a lot down, okay? So it depends upon these three things. And really, probably the most important thing is this one right here, and the setting itself on the spreader. Okay, and this is what we're going to do out here in just a second. We're going to go out there and see if we can roughly calibrate a fertilizer spreader. Need a scale. In this case, it's not as important to weigh it out. You can actually scoop it out. It turns out that 1 16-ounce fluid ounce cup weighs about a pound of fertilizer. That's a good estimate if you don't have a scale, which normally you don't. But a scale, some way to measure, spreader, fertilizer, tape measure, we've already done that, and some place open to put this down. A bare or paved area, just so you can see the pattern. You can do it on a grassy area too, but you can see the pattern a lot better if you do it on a bare area. But if you do that, you need to make sure you sweep it up or blow it off into the grass. We're going to use the grass area back out here. The kinds of spreaders that we're going to use, this is the type we're going to use here, just a regular push spreader. There's a lever control on the handle that operates a little puka inside that opens up more or less. There's a dial that you can set for that little puka being big or small, and that's what really regulates how much fertilizer comes out. That's the easiest way to calibrate it, by changing the dial on the spreader. That way you can walk at your own comfortable speed. Somebody else might walk faster or slower. You can adjust that for the setting on the lever on the inside. Sometimes on the bag of fertilizer, there's a suggested setting for that particular type of fertilizer. Oftentimes there is. In our case, there is too. If there's not, it's a good thing. This is a trial and error thing, kind of like Joe's was with the spray, to see how much. And basically what you're going to do is measure out 1,000 square feet. Some people like to use smaller amounts, but for this, 1,000 square feet is like a minute up and back, Measure out a certain area, 1,000 square feet's very convenient. And then figure out, depending upon what kind of fertilizer you're using, the analysis of the fertilizer, how much do I need to put down 1 pound of N? Or if you're going to put down 1.5, how much do I need for 1.5? Put it in the hopper and spread it and see how much you have. The easiest way to do that is to weigh out a certain amount, spread it, come back and weigh what's left, just like Joe did with the water. Or you can weigh it, but we're going to put the 10 pounds in, spread it, come back and weigh what's left to see how close we come. So it's a fairly simple and it's trial and error, especially the first time around. If you're not used to the spreader you're using, you may be way off. It's better to be way off not putting down enough than be way off putting down too much. Okay, so that's basically what we're going to do here. If you look at the pattern that a rotary spreader puts out, It's in the form of a semicircle out in front. Here's the spreader going in this direction, out in front of this direction. The total width of the throw might be, say, from here to here, but the edges have less fertilizer. So what you want to determine is what they call the effective width. It's about the middle 2/3 of that throw. So that's what you want to overlap, are these edges over here where it's 1/6 of it here, 1/6 of it here. So the first thing we want to do is to measure the effective width. If that's, say, 15 feet, as we're going down, it spreads it out over 15 feet. That means the middle 10 feet is where we're getting most of the fertilizer. And we want to overlap those edges by about 2.5 feet on either side. And that's one of the things that we'll do here. So it's just a trial and error thing to see how things go. Overlapping here again, up and back. Typical patterns, you're going up this way, coming back this way, you're overlapping about 2.5 feet on either side. So this area here would get as much as all the rest of it because you're overlapping. And that's important too. Some of these rotary spreaders, like the ones we have out here, if you're going along a sidewalk, you don't want to be throwing it over onto the sidewalk. They have a guard that you can put up. So it's only spreading half a circle instead of the full circle. But you don't want to be using that for calibration because you're cutting off half of that first strip. And you usually don't spread more than 1,000 square feet. So it's a good idea to use the thing wide open. Okay, what we're going to do here is set up a test plot. We've already measured out 1,000 square foot thing there. Calculate the pounds of fertilizer that we expect based upon the fertilizer we're going to be using. And we can do that right now. Okay, what we're going to be using is a homeowner type stuff again. Keep losing my... Go. It's 32, I think it's something like 4.8 or something like that. These two numbers don't mean anything as far as calibration. This is the one that we're looking at. Again, that's the N. So this one has 32% N, pretty high N. And if you read the label, we have the bag out there. You can read it when we get out there. It's got a reasonable amount of slow release stuff there too. It's not a bad fertilizer. So what we want to do is determine, first of all, how much of this fertilizer should we expect to put down over 1,000 square feet if we want 1 pound of N. And that's what we're going to go for. We're going to try to, change the setting, basically, so we can get this predicted amount. Well, our formula, again, going back to that, okay, here we go. Okay, here again, the recommended amount. Okay, let's all calculate this out. So we know the recommended amount we're going to go for with this one is 1 pound N. Okay, so we're going to have 1 divided by what? 0.32, because that's the formula we're using, times 1,000 over 1,000, or 1, because that's our test plot, right? So in other words, 1 divided by 0.32 is what? A little under 3? Okay, let's say 3. This is not rocket science, right? Okay, so what we expect now is to spread 3 pounds of that fertilizer, of the total fertilizer, which would give us 1 pound of total N. Okay, so that's our goal, is to go out there, figure out what the setting is on the spreader, spread it out, weigh it, see how close we come, reset it, spread it again, see how close. Trial and error. We shouldn't have to do that more than 2 or 3 times. And from that point on, whoever is spreading with that spreader can maintain that setting on the spreader. That's your calibration. Somebody else is going to walk faster or slower. They may be a little bit different. You may set it at 3, somebody else may set it at 4. So it's kind of an individual kind of a calibration. Okay, So we're going to do this right outside here. Let's all just kind of go right around the corner to the other side. Want to grab some water or sodas on your way out? Yeah. Okay, here the lever, and you can see here. Let's set this lever higher so you can. Okay, see, you can see here the little hookah opening up. You know. Okay, the higher this setting goes, the more it's going to open. Okay, the lower the setting goes, and they're pretty accurate settings. The less, so that's going to control how much fertilizer comes out. Okay, what we want to do is each individual doing this wants to maintain a fairly constant walking speed, what's ever comfortable, and depending on that and the opening, we're going to put down a certain amount of fertilizer. Okay. The recommended amount on this particular bag here, if I read it right, it is for this particular type, is 3 3/4. That's what it recommends for this particular spreader. So I'm going to set this at 3 3/4 right there. Now, if you see here, that's not very much. You know, that little puka there is not very, but this is a very fine prilled kind of a thing. So we'll see if they know what they're talking about. Okay, so the first thing I want to do is just make a real quick run to see how far this is going to spread. And that's going to determine our effective width. We've got this marked off at 20 by 50, so 1,000 square feet. And we'll see how many passes we actually have to make for that. So I'm just going to, one thing you need to remember too, once you open up this lever, what's going to happen? It's going to come out, yeah. And if you aren't moving, you've got a big pile of fertilizer there, right? So anytime you get down to the end and turn around, you want to let go of the lever, just like mowers and things, everything else. So once you get this going there, you want to get going first and then push the lever and then stop before. And it's going to throw it out 3 or 4 feet in front of the hopper. So let's see if this is set enough that we'll get a good idea if this is the right setting. Okay. We've got to basically from here to here. Mark, you have your right behind you. So say from here over. What do we got?
So a little over 8 feet.
8. Okay. So this particular spreader, if what we just saw there, is going to have an effective width of only about 6 feet. So if those 8 feet and the two 1 feet on either side, we have to overlap. So we're going to have to make, this is 20 feet wide, 6, we have to make about, what, 3, we're going to go up and back and over again for our total of 1,000, okay? So next thing we want to do is weigh out more accurately how much we have. So let's just pour this back into here. Okay, and we want to scoop out, since this is approximately 1 pound, I'm hoping, scoop out about 6 pounds. So you may have to just dig into there too. Yeah.
Dump this whole thing in here?
Well, we're going to have to pour it back. No, because we're going to have to pour it back when we measure. There you go. 2. There's 2. Let's go ahead and pour. 3. 4. Was that 4 or 5?
No, this is 5.
This is 5. Okay, there's 6 pounds, 6 scoops anyway, okay? How much do we need for 1,000 for 1 total pound of N? Will we figure it in there? W 1 divided by 0.32, remember? About 3 pounds, right? Is that right? Okay, so if we calibrate this correctly now, we should put 3 pounds of this fertilizer over 1,000 square feet. That would be about the right rate, okay? And to do that, we want to go up and back again because we're at about a 6 to 7 foot width. And we want to walk slow enough that we get a good spread, but fast enough that we don't waste stuff too. So let's see how we can do this. Okay, so we had 6 scoops or 6 pounds in there to begin with. We want to weigh what's left and see how much we actually use. What should we have left if this is right? Should have 3 pounds left, right? Okay, let's scoop her out here and see, Mark. Pardon. I got a good full scoop. 2. 3, a little bit. Let's say that's 2.5. We can. 3. Okay. So we have this much left over. That means we didn't put down enough, right? So what do we need to do?
Adjust it.
Yeah, adjust it would be the easiest thing to do. Go from, say, to maybe say 4.5. Okay. Want to try that one time? Okay. Let's put 6 scoops back in again.
About 1.5 pounds.
Yeah. Yeah. So we only put down about half as much. Pardon?
3 scoops.
3.
And there's still left.
So you had what, 3.5, and 3/4 something, the dial?
The dial at 3 3/4, yeah.
You double it?
Well, that's trial and error. What do you want to do?
You use all that would it
What? No, keep talking. You're right. You're right. Yeah.
double, just double?
It logically it would
Yeah,
seem
what
that.
yeah.
So want to set it at 7?
I would say that. 6.
6? Okay.
It's gonna be coming out too fast.
Okay. 6. Okay. Yeah, you're right. You're right. This is trial and error now, but yeah, I mean logic would say that to me too. Okay, good. Okay, let's put 6 back in. Because we're still expecting 3 pounds, yeah? And we only used 1.5. We used half as much. Oh, sorry.
So this would be much safer for using pesticide. I mean, we don't have those insecticide that's granular thing.
Yes.
Safer to spray this instead of
For a granular insecticide. Joe, what do you think? Granular pesticides better than spray? Safer?
I would still protect myself because granular insecticides are going to have dust. Just because it's granular, I would say, don't just say it's safe. Because now when you got granular and you're pouring it, dust is floating up. That's going to be more concentrated than if you diluted it, spray it. So I would still protect myself. I wouldn't say it's any more or less safe. There's risks with both systems.
Might be a little bit easier to put down, possibly.
It might be easier because the spraying requires the mixing. If it's a ready-to-use granule, then it's like this. You can kind of see what the rate is. It's probably easier. The spraying requires overlap. If you're going to try to treat this whole area, requires overlap, a consistent forward speed, a consistent rate of flow as well as a consistent height, so you get the proper open up. There's a lot of things that you got to do like a machine. So
yeah. Actually, granular insecticides are more common than granular herbicides. Am I right there?
I would say
Yeah. Yeah. Okay, so let's, we've got another area on beyond here marked out. We'll put that on here, do the same thing. So we're set at 6 now instead of 3 1/4.
What are the signs of heat stress? Yeah.
What do you think? Maybe a little too much, huh? We'll see. Okay, we expect it. See? Okay, let's, we'll probably just dump it.
Way too much.
Yeah. Well, you really don't know until you know see how this particular rotary spreader works.
Made in Germany.
No wonder, huh? 1, yeah, 1.5. So we were half as much the first time and twice as much the second. So yeah, so here again, we want to do this, we won't. You just keep going back and forth until you get what you get. So it's going to be nice and green. Yeah, so that's the idea behind it. Now for that, once we determine what the setting is for me, every time I use this fertilizer, it should be the same. For somebody else that walks faster or slower or whatever, it'll be a little bit different. Okay? Okay, let's go back inside and take a quiz and take a break. Okay, let's go real quick. Number 1, the most common mineral nutrients plants need are nitrogen, iron, and magnesium. What are the 3? NPK, nitrogen, phosphorus, potassium. Number 2, a fertilizer with the numbers 29, 210 contain 29% phosphorus. 29% what? Nitrogen. Number 3, most rural medians and roadsides will require little or no fertilization on a regular basis. The DOT, true. 4, the easiest and most accurate way to spread fertilizer is by hand. False. Some kind of spreader. 5, fertilizers should not be used close to streams, drainage ditches, and waterways. True, because of pollution. 6, ultra slow release fertilizers are far more likely to cause pollution than quick. False. 7, calibration of a spreader takes into account three things: type of spreader, kind of fertilizer, and how fast the spreader is pushed or pulled. True. And also one other thing would be what? The setting on the spreader, right? Yeah. 8, the ultra slow release fertilizers need to be applied several times a year in Hawaii. False, if we used them only once. Number 9, fertilizer application rates are based on how many pounds of potassium are needed. Pounds of what? Nitrogen. 10, guaranteed analysis on the back of a fertilizer bag contains information on how much to use. What's it really say? You can use that to determine how much to use, but what actually is on the back of the label on the analysis? It's what's in it, right? What's in the fertilizer. And the most important thing to look at is what kind of nitrogen. Yeah, but you can use that to calculate rates too. True and false. Yes and no. 11. Spreader calibration is not really necessary to get an accurate application every time. No, yeah. I'm sorry, not necessary. Didn't say every time. That's false. It is important at least to get it set the first time. And after that, you can assume everything's the same if you're using the same stuff. So that would be true. It's not. I'm sorry, false. Long day. 12. It's best to mow immediately after applying all types of fertilizer. False. You don't want to chop up those slow release kinds. 13. It's best to apply an extra amount of fertilizer on bare slopes to encourage ground cover. False. That'll cause erosion, pollution due to erosion. 14. It's very important to irrigate immediately after applying quick release and slow release nitrogen formulations, such as sulfur coated. That's true. Yeah. Yeah. You want to water it in. Not so much the ultra slow, but these other kinds. And finally, 15. Yeah. The amount of fertilizer to apply to trees and shrubs is calculated on the base of 1,000 square feet of root zone underneath the canopy. True. Yeah. That's the area you use. Okay? So hold on to those for your review.